All right, just a quick review on mole ratios and how important they are. So let's say if we have this problem, given the balanced reaction representing a reaction, 2H2 plus 1 O2 yields 2H2O plus energy. What mass of oxygen completely reacts with 4.0 grams hydrogen to produce 36 grams of water? All right, so which mass of oxygen are, so what do we do here? Well, the thing about this reaction is that one way you can interpret this reaction is that you have two molecules of H2 plus one molecule of O2, and that yields two molecules of H2O. That's a perfectly fine way to interpret it. But another way to think about this reaction is if you have 2 moles of H2 plus 1 mole of O2 yields 2 moles of H2O. And this is a very powerful tool, right? This sets up ratios kind of between these values, all right? So kind of what do I mean by that? Well, now 2 moles, in order for this reaction to work out, right, you need 2 moles for every 2 moles of hydrogen gas that you have. You're going to need 1 mole of O2 in order for this reaction to sort of work out, right? If you have, let's say, 4 moles of H2, well, then you're going to need 2 moles of O2, and that's going to yield 4 moles of H2O, right? We sort of just multiplied this sort of equation by 2, right? If you have 2 times the reactants, you're going to get 2 times the product, right? And that kind of makes sense logically. So how do we approach this problem, right? If I have 4.0 grams of hydrogen, and then, blah, 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 what mass of oxygen is needed? Well, for starters, whenever you see this grams, well, we're dealing with mole ratios, right? So you're going to convert the grams, into moles. Now, if I have 4.02 grams of hydrogen gas, right, because hydrogen gas is in my equation, well, I know that the molar mass for one singular hydrogen is approximately 1, right? For H, it's approximately 1 gram. So that means that if I have H2, well, that's going to weigh about 2 grams for every 1 mole. So doing the math, we get about 2 moles of H2. All right. So instead of this 4.02 grams of hydrogen, well, you can kind of just replace this with 2 moles of H2. So the way to interpret this problem is which mass of oxygen completely reacts with 2 moles of H2 to produce 36 grams of water. All right. Now, in this equation right over here, when we have 2 moles of H2, well, that requires 1 mole of O2 in order for this reaction to work out, right? So in this case, if I have 2 moles of H2, well, I'm going to need 1 mole of O2. 1 mole of O2 for this reaction to work out. Now, we need to find out the mass of oxygen, right? We found out that, in order for this reaction to work out, we need 1 mole of O2. But the problem is that this question is asking us for the mass of this. So mass, we're going to be talking about grams, right? So you're going to have to convert back from moles to grams. So in this case, in 1 mole of O2, well, a singular oxygen atom has a molar mass of about 16 grams. So that means if we're dealing with O2, well, it's going to weigh about 32 grams, right? Because it's double. This is 1 singular oxygen, right? So if you have 2, 32 grams, right? So 2. So we're going to say that for 1 mole of O2, it's going to weigh about 32 grams. The moles cancel out, and you're just going to be left with 32 grams of O2. So this is the amount of O2 that's needed in order for this reaction to sort of occur. Meaning that if you have 1 mole of O2 and 2 moles of H2, it's going to lead to 2 moles of H2O, and H2O has a molar mass of 18 grams. So if you have 2 H2O, well, that's going to be 18 times 2, which is 36 grams. And that matches up with what the problem is saying, right? When you want to produce 36 grams of water. If you start, ammonia is produced by Haber process. If you start with 10 grams of nitrogen gas and 10 grams of hydrogen gas, which reaction is the limiting region? How many grams of ammonia will be produced? So what the hell is a limiting region? Or it's also sometimes known as a limiting reactant. All right. And limiting reactant, it's kind of in the name. All right. It's kind of the reactant that limits the amount of product that can be made. All right. So for example, right, let's say if we have a reaction where I have, let's say, 3 moles of N2, and let's say if I react that with, let's say, 100 moles of H2, all right, how much N2 is this, how much NH3 is this going to produce? Well, it turns out that this will actually produce 6 moles of NH3. Now, you might be asking, why? Well, it's because, right, think about it. Even if I have this much H2, right, I have 100 moles of H2. Well, guess what? I only have 3 moles of N2. So eventually, all this N2 is going to be used up. And even though we have this H2, well, it's going to have nothing to react with. So you could say that this N2 right over here, this N2 is the limiting reactant, right? Because we have so little of it, well, that limits the amount of product that can be made. And in this case, notice how we use the mole ratios, right? We saw that in our original equation, 1 mole of N2 plus 3 moles of H2 gives us 2 moles of NH3. So we have 2 times the amount of NH3 than N2. And look at the case here, 2 times the amount of NH3 than N2, right? So yeah, when you're kind of dealing with calculations, mole ratios involving limiting reactants, the key to know is that you're going to use the mole ratios based on the limiting reactant, right? You're not going to say that this is going to produce, if I were to use the mole ratio here, you're not going to say that this is going to produce 200 over 3 moles of NH3, right? You're not going to use the mole ratio between hydrogen and NH3. You're going to have to use the mole ratio between N2 and NH3 because N2 is the limiting reactant, okay? So yeah. So in this case, which reaction is the limiting reactant? Well, I have 10 grams of nitrogen gas, 10.0 grams of nitrogen gas. Now we're going to have to convert this to moles because mole ratio, stuff like that. All right, so N2. So for nitrogen, that's about 14 grams. So if I have N2, that's going to be 2 times 14, which is going to be 28 grams for every 1 mole. And if I do this, this is going to be around 0.357. 0.357 moles of N2. Now let's do it for hydrogen gas. So hydrogen gas, we have 10 grams of hydrogen gas. Now we know that for every 1 mole of hydrogen gas, it's going to be around 2 grams, right? Because for 1 hydrogen atom, it's about 1 gram for its molar mass. So if I have an H2, it's going to be 2 times 1, which is just going to be 2. So this is going to be 5 moles of H2. Now, just from like the looks of everything, it looks like our limiting reactant is going to be N2. Kind of just by kind of looking at this, right? If I were to look at this reaction, right? In this case, I have 3 times the amount of H2 as N2 in order to create NH3. But in this case, notice how I have way more H2. I have, right, this is 0.357 moles of N2. Well, I have 5 moles of H2, right? This is way more than H2 than I need. So my limiting reactant, the reactant that's going to limit the amount of product that's going to be made, is going to be this N2 right over here. And if I wanted to check my work, well, what I would do is I would multiply the amount of N2 I have by 3, right? Because normally there would be 3 times as much H2 as there would be N2. So 0.537 times 3 is going to be about 1.07 moles of 1.07 moles of H2. So, if I were to have kind of the perfect, if I wanted a reaction where everything reacted, right? So, this reaction right over here is a reaction where if I reacted 1 mole of N2 with 3 moles of H2, everything would react and I would get 2 moles of NH3. So if I wanted a perfect reaction like this to occur where all of my reactants reacted and turned into products, well, I would need 0.357 moles of N2, and I would need 1.0 moles of H2. But obviously in this case, the reaction all of the reactants aren't gonna react because I have way more H2 than I really need, right? So yeah. But that's kind of how you would show your work in this case, you would just use kind of the mole ratios and all that. All right, so how many grams of ammonia will be produced? Well, notice here how I have 0.357 moles of N2, and for my mole ratio, for every mole of N2 that I have, it's going to be 2 times the amount of product. So I'm just going to multiply this by 2. All right, so, or you can say that for every 1 mole of N2 that I have, it's going to have 2 times the amount of product, or NH3, right? It's going to produce 2 times the amount. So 0.57 times 2, that's going to be 0.714 moles of NH3 that's produced, right? This many moles of NH3 is going to be produced. Now, we're trying to find out how many grams of ammonia. So, now we just have to convert from moles to grams. So how do we do that? We just have to use molar mass. So N weighs about 14 and hydrogen weighs about 1. So we have 3 hydrogens. So 14 plus 3 times 1 gives us 17 grams. So we are going to do for every 1 mole of NH3, 1 mole of NH3, this is going to weigh about 17 grams. And doing the calculations, we are going to get around 12, all right, about 12 grams as our final answer. And yeah, that is going to be the mass of the NH3 that is going to be produced.